Hello, everyone, and welcome to the session of the AI Nurses Network webinar series. Today, we've a great speaker, Dr. Nathan Blake, who's a nurse based here in the UK. And he splits his time between University College London and King's College London, and he's going to talk to us about explainable AI and why scrutinising machine learning models that are applied to medical data is important. So,
Cool. Thanks, Siobhán. So, like you said, so I work at King's College London, in the Department of Informatics. I split my time there and at UCL, but it's mostly in my capacity at King's that I'm going to be talking to you today about explainable AI. So there I'm a postdoc researcher and I work with Hannah Chokla, who's a professor of AI, and her team. We've developed an explainable tool called Rex, and that's what I would like to talk to you today about. So explainable AI, what is it? 1 second, the slide's not responding as I'd hoped. I'm just going to stop sharing a second.
no worries, take your time. You can,
I'm just going to share my whole screen. I think that'd be easier.
perfect, that's coming up.
There we go. Should always stick to what you know, right? Try these new fancy things. So, like I was saying, so I'm going to talk to you today about explainable AI. So what is explainable AI? Let's start with an image. I'll be talking about images a fair amount of times just because they're sort of slightly more intuitive to understand, but this applies to just about any sort of data type. So imagine you have an image. In this case, we have an MRI slice of a brain, but we've trained an AI model to classify it. So in this case, a deep neural network. There's various sort of neural network architectures out there, all coming under the moniker of AI. So we've trained our model, and we want to know whether this particular image is cancerous or not. So it gives us an output. In this case, it correctly says that we have glioma. And that's all well and good. That's great. And we get our performance metrics, how often does it get it correct? How often does it get it wrong? But it still always begs the question of, well, why? Why did this particular AI model classify this particular image as being glioma? And these especially sort of modern AI models are particularly notorious for being black box, just being these huge inscrutable objects. So even if you do have access to the weights, you don't really, they're so big, many billions and billions of parameters, you don't really know what's going on. So to that end, people have been developing various methods of trying to peek inside the box to find out what the AI model is actually doing. So I'm going to talk to you today about one of those, which is referred to as explainable AI. Just a bit of a warning that this is one of those, especially some medical AI. It's a truly cross-disciplinary domain, and so people don't use the same words consistently. So there's many words such as transparency and explainability, interpretability. I think that the latest one I came across, mechanistic interpretability, which sounds pretty cool actually. It's like neuroscience for AI models. But there's lots of tools out there, and the one I'm going to talk to you a little bit about today, Rex, is a particular implementation of this. Each of them have their own strengths and weaknesses, but the family of explainability tools that Rex belongs to, which are sort of broadly speaking, sort of post hoc methods. So they're methods that you add, sort of an algorithm that you add at the end of your deep learning network. So it's a separate entity to your deep learning network. What they have in common is that they all provide an explanation of some kind. So in this particular instance, this is what a Rex explanation will look like. And what it does is it just finds the subset of pixels which cause this particular image with this particular AI model to correctly classify as glioma in this particular case. And so as you can imagine, that just gives some intuition as to what the AI model is doing, what features it deems are important, or we'd say responsible for causing this particular diagnosis. So I think for some people, that'll be fairly intuitive as to why you would want to have explainable AI, but it's not ubiquitously accepted. So I'll go on to quickly just say about why we do need and want explainable AI. And you can sort of put them down into two sort of main camps, maybe a top-down approach from a regulatory perspective, and also a bottom-up approach, so more from a sort of clinical demand sort of perspective. We start with a regulatory perspective. There's quite a lot of regulation now coming around AI. I've gone with the EU's AI Act. Even for those of us outside of the EU, I think it's still going to be highly relevant because many countries, even outside, will adopt these sort of best sort of standards. And the EU AI Act, they make provision for high-risk AI systems, of which medical AI is pretty much all medical AI is going to fall into that category. And they say that these systems should be designed and developed to ensure sufficient transparency. So you can always see the different words that they're using. So sufficiently transparent and allowing interpretability of a system's outputs. Like I say, this is just one example of the regulatory sort of demands for some kind of transparency or explainability. But there are many others. But then we can also take it from sort of what I call a bottom-up approach, where you've got clinicians, healthcare practitioners who are going to be using these AI models. And you can imagine, you're asking a practitioner to make a decision about their patient based on what an AI system says. It's perfectly valid for them to ask, well, why are you recommending this course of action? I'd like some recourse to that. So again, there's lots of guidelines coming out now. For me at the moment, I think the best ones are something called the Future AI Guidelines. I think anyone interested in the medical AI space should probably at least be aware of Future AI Guidelines. And it's just a set of guidelines for anyone thinking of AI in a medical space, everything just from the very inception of an idea all the way to deploying it in a real clinical setting and everything in between. They try to capture the whole remit. And they sort of whittle it down into 6 sort of main principles, of which explainability is one of the 6 main principles. They don't say that you have to have explainability, but they do say, you need to consider whether explainability is needed for your particular application. And further than that, they say that if you are going to have explainability, then you should assess the explanations themselves. So like I was saying before, you have sort of 2 ends to this. You have the AI model itself, and that should be rigorously assessed. But then the explanations or the explainability tool that you're using itself should also be validated. And that's something that's quite often missing, as we'll see in the next slide. So like I was saying, explainable AI is not universally accepted. Not everyone thinks that we do need it. To cut quite a long and nuanced story down into just sort of two sort of headlines, I'd say. There's 2 main reasons that people object to explainable AI. One of them is based on the question of, is it really needed? So, modern clinical practice is based on evidence-based medicine. Whereas, for instance, we use, lots of us give paracetamol, prescribe paracetamol all the time. We don't actually really know at a fundamental level how paracetamol works. But we do know its efficacy profile extremely well. We know its safety profile extremely well, to the point that we can be extremely confident when we're given paracetamol. And that's despite not knowing precisely how it works. So in the same vein, people say we don't really need to know how AI works. We just need to know that it works and that it undergoes rigorous trials and proves itself time and time again. And we might inevitably AI is going to fail in some instances. So long as we quantify that in some way, that we don't really need to know how it works. I would say to that they're not mutually exclusive. We absolutely need that sort of rigorous assessment of AI, but there's no reason we couldn't have explainable AI on top of that as well. Would be my perspective. I think the other criticism of explainable AI is perhaps a bit more nuanced, and that's the simple question of, is it good enough? So I mentioned there's lots of guidelines out there at the moment about just sort of deploying AI in a medical context. And some do, like the Future AI Guidelines, do recommend using explainability, and others don't. And when they don't, they generally say explainability would actually be nice, but it's just not good enough at the moment. So I think there is a sort of real point there to be addressed. And just to speak to that, here's some early research my team did when we were developing Rex early on. And we just wanted to compare Rex to sort of other common explainability tools out there. So just talk you through this slide quickly. There's 4 MRI slices across the rows. So each row is the same slice of brain. They all have glioma present. And in this case, they've all gone into the same AI model, and they've all been correctly classified as having glioma present. So that's great. So we have our AI model. It says glioma is present. Now we'd like to know, okay, why does this model think these particular MRI slices are positive for glioma? And as you can see just at a first glance, the different explainability tools give different explanations, even in those instances where they sort of do all incorporate the tumor in some way. You can see there's quite a lot of noise around that, which quite distracts from what really is the explanation. Now, none of this is to say that Rex at the moment is any better or worse than any of the other ones. It's just to say that, well, if you've got these different explainability tools and they all give different explanations, which, if any of them, is the correct one? And that's an active research question. That's what I'm working on at the moment. That's where the literature is at the moment. I think people need to really start addressing this question of how do we really rigorously assess the explainability tools themselves. And it's surprisingly tricky, actually, because you need some sense of a ground truth of what's going on. So that's where we are at the moment. So like I say, the team I work with, we develop one particular explainability tool called causal responsibility explanations, which we describe as REX because that's how modern acronyms work apparently now. I'll just give a quick high-level overview of how REX works. So I'll talk you through this quite busy slide. So we start with a particular image that we want classified, again, in this case, MRI of a brain. And we have a model that's already been trained. So we have a trained model, and that's what we want to explain, this particular image, given a particular model. So the first thing that we do is we randomly partition the image. In this particular case, we've got 4 partitions, and we randomly blank out some of those partitions. So we zero them out in this particular case. And we then send this partially occluded image to the classifier. And the classifier will either say, no, okay, that's cancerous glioma, or it's not. If it says it's glioma, what we say is, okay, so what we didn't blank out was responsible for the positive classification of glioma in this case. And since in this particular partitioning, there's only one sort of positive partition, let's say, it takes all the responsibility. So we give it a responsibility of 1. Okay, we then sort of drill down into that particular partition. So we blow it up, and we again randomly partition that. And again, we randomly blank out some of that some of those partitions. And for those partitions which are needed to be present to get the classification of glioma, again, they share responsibility. In this particular instance, there are 3 such partitions that are present, so they share the responsibility. So they all get 1/3 responsibility, and so on. We drill in further and further into these partitions further and further to get ever more sort of nuanced and closer to what's going on. And then we just iterate through that process a few times because these are random partitions. With any sort of random process, you're going to want to repeat this a few times to make sure you're getting, just by bad luck, you're not getting something a bit silly. And so by doing that, we build up what we call a responsibility map, which other people might look at as a saliency map. And from that saliency map or responsibility map, we can extract an explanation, which hopefully will tell us then what the AI model is looking at. And so that was a case of an MRI. So that was a 2D image MRI. We've been applying Rex to many biomedical data sets. So as a student who's looking at applying it to histopathological images alongside transcriptomics, Got people looking at CT scans, so that's no longer just 2D, but in voxel space, so 3D images. We're just hopefully starting to work with some cardiologists at Imperial to look at explaining ECG classification. And in my work at UCL, actually, I work on Raman spectroscopy. So that's a type of vibrational spectroscopy. So I'm looking at explaining cancer diagnostics using vibrational spectroscopy. So I just wanted to give you that sort of a rough idea of the many different types of data that we're applying this to. And we're looking to apply it to many more data types. So we're always looking for collaborators or people willing to look at other applications. And so this slide, I was just sort of thinking off the top of my head, like if I was still in clinical practice, the kinds of things I'd be interested in applying REX or explainability to. So, I've already seen a few early papers out there looking at early warning scores and applying AI to early warning scores. Well, you can well imagine why having an explainability component for early warning scores would be very helpful. If an AI is saying, okay, your patient's at risk of sepsis or whatever, it'd be very nice to know, well, which vital signs or which combinations of vital signs was the AI using to make that prediction. And that just helps you to actually be able to act on what you're doing. Some other interesting ones I came across, people have been applying AI for tissue viability. That's both just normal sort of white light images and also using thermal images, apparently, which is quite cool. But again, you can well imagine why you'd want to be able to have an explanation of why does an AI model think a particular patient is at risk of tissue breakdown, especially where is that tissue going to break down. And something maybe a bit closer to my heart, accident emergency triage. So I've been starting to review quite a few papers now using large language models to see if they can triage patients as well as nurses can using something like the Manchester triage system. But again, even if it does well, you're still going to have the question of, okay, well, which keywords or vital signs is the LLM using to make that recommendation? And that's something we'd in particular be interested in, us working on REX, because that's explaining LLMs brings some unique sort of technical challenges that we'd love to get our teeth into. So that's just sort of a high level overview of what REX is. And I think more importantly, what it does and what we apply it to. So like I say, we're always looking to work with people, looking for collaborations. So if you did want to get involved, feel free to get into contact with us. If you just want to start using REX out of the box, it is ready to use. So you just scan the QR code there, which takes you to the GitHub website. So if you already have a programming background, you just want to start using it, and you have an AI model, then you can absolutely start using it. You can also read the documents as well just to get started. However, what we found is it's rarely the case that you can take any explainability tool and just start using it out of the box. Just about all of them have been developed in a general sort of setting. And then people take it and apply it to biomedical data. And what we found is biomedical data is sufficiently different from, say, normal data, such that they don't just work out of the box. You need to sort of tweak it a little bit and play with the parameters and various other heuristics going on under the hood. So if there is a particular type of data that you want explaining, and the existing explainability tools aren't quite working for you, we'd be more than happy to work with you to get it working. And I think that's the real strength of REX, is that it's under active development, and we're more than happy to liaise and collaborate with people. For anyone who's sort of just more interested in AI in a sort of general sense, so my funding comes from CHAI, which again, one of those acronyms, modern acronyms, Causality in Healthcare AI Hub. So they're a group of academics, principally from a quantitative background. And so at the moment, there's quite a lot of buzz in the AI community around causality, just because, data sets in medicine are just huge and so heavily correlated. If we could tease out some kind of causal pathways amongst that data, it should help our prediction models be much more robust. So that's what they're interested in. So if that's also of interest to you, you can go to the CHAI website, and they're always looking for collaborators in healthcare practice. So just hit one of us up and we'll be more than happy to talk to you. You can always just follow me as well. I have my own blog post where I just sort of blog about medical AI in a more sort of general setting. So feel free to follow me there as well. Thank you.
That's great, Nathan. Thanks. I've actually read some of your blogs and they're great. So I'll share them
Thanks.
on the LinkedIn group for the network. I just have a couple of questions before we finish, if that's okay.
Yeah, of course.
Yeah, and I guess I'd really like to know, as a nurse, how did you become interested in AI and start doing research on it?
Yeah, so yeah, my path is perhaps a bit circuitous. I've sort of left nursing and sort of now getting back into healthcare. So it's actually a lot of serendipity. So I was working at Imperial College at the time, and there's a charity attached to them, and they put some funding up for a master's. And so one of my colleagues, Mary Darwood, sort of encouraged me to join, and I did. And they had a module on statistics. And I realized then, I was about what, 30 at the time, that I really loved maths. So after that master's, I started doing remedial maths courses at Open University.
Right.
And this was way before sort of AI was really a thing.
Mm-hmm.
Eventually, I did enough courses that Birkbeck College let me do a master's in statistics. And that's what got me on to did a PhD in computational biology. And it was there that I really became aware of AI, because around the time I started my PhD, sort of neural networks were starting to become a thing. When I first started, it was still people still playing around with random forests and sport vector machines, which are still probably underused now. There's so many more problems that could be solved with simpler systems, but we all go to what we call AI now, which I guess is just neural networks. So that's how I sort of that was my path into AI. And then it was once I'd started doing my PhD and sort of getting into the thick of my PhD, I started working alongside histopathologists. And then when I left to go to King's with Hannah, I started working with radiologists and oncologists, cardiologists. So I've sort of started to get back into healthcare. But it would be great to start working with nurses, because like I said, I have worked with quite a few healthcare professionals, but not so many nurses now. So it'd be nice to work with some.
Yeah, I think it's great. You could see how Rex could be applied to nursing data sets if they were sort of readily available, but they're a bit more tricky to get hold of, I think. So it's just something we
Yeah.
need to work on. I was wondering if you had any advice, yeah, for nurses who maybe want to learn a bit more about AI and get into AI research. What could they do?
Hmm. Well, I think two things align here. So, clinical AI is one of those truly cross-disciplinary sort of domains. So there's many ways to get involved depending on what you want to get involved with, and that ranges from right getting down into the nitty-gritty nuts and bolts of it, all the way just to the sort of higher level sort of even sort of the sort of social aspects of how computer human interfaces. So we're going to need nurses in the whole remit of that. And I think nursing is quite nicely placed in the sense that it's the most diverse workforce I've ever worked with. I've had a few different jobs now, and nursing is by far the most diverse workforce I've worked with. So there'll be nurses who are sort of minded to go one way and nurses who are minded to go other way. I think I'd like to speak to the nurses who are sort of more minded to go into the sort of computational end and sort of more nuts and bolts end. So
Sure.
that's the path I went on. But I know I'm not the only one. I worked with a colleague of mine in A&E, Maxwell Flynn. He's gone on to write books in Rust. Rust is quite a low-level programming language, and so he's pretty much the sort of UK Rust expert. There was another guy I was working with who was studying astrophysics on the side. So I know you nurses are out there. So if you are interested in learning the maths, learning the programming, there's lots of resources out there. I got started with Khan Academy, which is I think it's meant for kids. Um, but it was great. I learned maths with Khan Academy. It took me all the way from literally started with a video of 1 + 1 = 2. And I finally stopped following Khan Academy only when I started my master's in statistics. And that's the sort of the level it spans. That was truly great. For
Brilliant.
programming, I mean, I, I guess I got my head around it during the COVID years. I actually sort of built my own neural network. So not using PyTorch or TensorFlow or something. Just built my own. I say built my own.
Brilliant.
I was following Andrew. I think he was one of the founders of Coursera, but he has some free courses on YouTube, and you just follow them, and he'll explain the maths and he'll explain the code, and you just code up your own neural network. So there's lots of resources. You can just go out there and get started. And that's the thing. I think the great thing about programming is that you could just download Python. You could just get started, just playing around with it, and just make a little game, or start playing with fractals or whatever it is that just whatever floats your boat. You can just start playing with it. Other than that, I'd say reach out to people. So if you've got a little bit of technical background, it doesn't have to be much, by the way. I say technical background, even just a little bit. You can start reaching out to people such as the AI Nurses Network. Researchers like myself, AI researchers are always looking for clinical partners. So if you're a healthcare practitioner, just keep an eye out for these sorts of people, and just keep an eye out for little sources of funding. I mean, I'm outside of the NHS now, but I remember being when I was in the NHS. Hopefully it's still like this. If you keep your eyes open, look on sort of on the internet, there's little pots of money pop up here and there. So just keep your eye out, look out for what's going on. The government has a big push for both AI and healthcare. And, if you put those two things together, AI and healthcare, it's more than likely there's going to be a little pot of money somewhere. So just keep your eyes open and just dive in, I would say.
Brilliant. Yeah, thanks. There's loads of good suggestions there. And yeah, I think the open source community around AI is great. There's loads and loads of resources online and people, you can reach out to. So thanks so much for that. And my last question is kind of a hard one, but where do you think AI is going to go in the future, and what kind of trends should nurses be keeping an eye on?
Predicting the future. Yeah. So maybe I'll give it like a short term and a mid-term sort of prediction. So short term, actually, I think at the moment we're in a hype cycle. There's so much hype around AI. And I think at the moment we're somewhere around the peak of inflated expectations. So, which means there's only really one way to go, and that's the trough of disillusionment, which is not to say that AI is actually going to get any worse. It's not that AI is going to stop progressing. That's going to continue to progress. It's just the expectations around it. So I think in the short term, what you might start to hear is people start to be disappointed that AI is not delivering everything that was promised. It probably won't cure all diseases in 5 years' time, for instance. And so that can get interpreted as being, AI is just not as good as we expected, and it won't be in the short term. But after that trough of disillusionment, that's when AI progress will sort of really become embedded in medical practice. So I'd say, if you're a nurse thinking about getting involved in AI, and then whenever it happens, people start talking down about AI, that's actually a good sign. That's the best time to get involved, actually, because I say these hype cycles are sort of quite well defined, and same things happened with the .com bubble. In the early days of the internet, you had all these companies come out. AI is going to internet's going to take over the world, and it didn't quite then. So a lot of companies went bust, and of course, a little bit later, the internet did take over the world. So I think the same sort of thing is going to happen with AI. Medium term, starting to get a bit, even medium term's hard to know exactly what's going to happen. I think we're going to start to see, especially in sort of medical practice, more sort of AI, human, sort of tandem working. So it won't be, I think we'll be a very, very long way away from AI replacing any expert human, but we'll see AI becoming increasingly part of any professional's working life, working together. And it's interesting because, humans, we often get it wrong. We often have modes of failure, and AI is going to have modes of failure as well. It's just inevitable. But what we want to do is build systems where those two modes of failure don't overlap. So, if the AI fails, human can pick it up. If the human fails, AI can pick it up. So that'd be a great way of working. I think the risk is one of infantilization, where we've started to become too reliant on our AI models, especially if we start working with them in our daily lives, and they're right time and time again, we might just become increasingly complacent and maybe start to lose some of our skills. So I think that's the risk, and the way to mitigate that risk, like I say, is this tandem working where you're working alongside the AI, and you're not just letting the AI tell you what to do. And this is where explainability sort of plugs into that. You're always keeping an eye on the AI system and make sure, okay, is that making sense? And when the AI system asks you, have you done this wrong? You don't just accept what it says, you really think about it. And I think that way you get a really synergistic sort of meeting of AI minds and human minds.
That's great.
That's my
Thanks. Well,
guess anyway, but future, who knows?
yeah, I think I'll be along the same lines. I think it will be a good supportive tool going forward, bearing in mind it has its limitations. So hopefully we'll see more nurses use AI in the coming years, and yeah, that it will improve our practice and patient care. So thanks so much for your presentation, Nathan. It was great, and we look forward to seeing more of Rex rolling around in different areas of medical and nursing AI. Thank you so much.
Well, thanks for inviting me.